Hi, my name is Arjun Chaudhary, and welcome to Energize the Tech Revolution. Today, we have a very special guest amongst us. ANDREJ SIMJANOV didn't always dream of designing high performance buildings, but once he entered the field, he discovered a powerful way to put his attention to detail to work. With a career that spanned contracting, manufacturing, energy modeling, and commissioning, he has built a unique foundation that now fuels his leadership in sustainable building design. What's even more interesting is that energy efficiency is just one piece of the puzzle. It now seems that there are even more meaningful goals we can achieve through thoughtful design. And today, he is here to share that journey with us. In his current role, Andre has had a hand in mechanical design, in energy modeling, and commissioning. So it's a role that embraces high performance buildings in many ways. Welcome to the show, Andre.
Thanks, Arjun. Thank you for having me.
Absolutely, Andre. So let us start off by learning a little bit about your educational journey. Now, you have a diploma in mechanical and thermal engineering and a master's in mechanical engineering building systems. What inspired you to pursue mechanical engineering and then building systems? Would love to learn more on that.
Um, it's an interesting question because I can't really honestly say that this is what I've always wanted to do. And now being in this role, it's a dream come true. I enjoy my position tremendously, for sure. Um, I think what probably contributed most is that I seem to have a good understanding of the physics around me. Um, and I am now, and maybe always have been, interested and maybe fascinated by heat transfer. And these traits seem to lend really well to the field of mechanical engineering. And then beyond this, I also have realized that I can actually focus on a detail on any detail like a great deal, and probably keep that focus for a long time. And that is a really good trait to have in energy analysis when you have all these little things that you always have to keep in mind and pay attention to. So I seem to have found myself in a position that I can really put my strengths to a good use. So I think things are working out pretty well for me at the moment.
Amazing and so happy for you, Andre. Now, in terms of your professional journey, you started off as an HVAC engineer and now you're leading the design of high performance and sustainable buildings. Could you share more about your professional journey?
Um, uh, I, I almost, may not sound really good, but I almost stumbled into this field. The field, first of all, the field of high performance buildings covers many aspects of design and many aspects of engineering. And the exposure I've had over the years really seem to be coming together. So it's true. I started as an HVAC contracting. This was in the Middle East, and it was right after my undergrad. After that, professional life-wise, I spent a couple of years in HVAC manufacturing slash design. Um, that really put things in perspective even more to see how things are even built, how HVAC equipment is being built. Then I went into energy modeling, then into commissioning. And I think currently I'm in a role that in a mechanical design role, but which includes a lot of aspects of energy modeling, some aspects of commissioning. So I'm able to wear several hats and cover a lot of ground when it comes to high performance buildings. So it has been an interesting journey for sure.
That's great to hear, Andre. Now, for the benefit of our viewers and listeners, could you differentiate what is the difference between a standard building design and a high performance or a sustainable building design? What exactly are we trying to achieve here?
Standard or typical building contrasted to high performance. Okay, so high performance first of all includes many aspects of design. It includes some passive design features and some active design features. So passive design aspects would be around the building envelope. So it would be strategies that promote solar heat, such as strategic placement of windows, careful selection of window properties to allow a lot of solar heat into the building. But then it also includes means to block the summer sun and mitigate cooling. So, it would include things like windows overhangs or fins, improved permeability, or I'm losing the word, like limiting infiltration, passive means like this. But then once those are exhausted, then passive, but like when the passive means are exhausted, then the high performance design would include more active features. Like, for example, this is where mechanical design really comes to shine. So for example, heat pumps that can provide a lot of the heat, maybe most of the heat, and all of the cooling, and perhaps being especially good in training heating and cooling when the ambient conditions design or require both. So and then and then high performance buildings would, or buildings design would, always include like early energy analysis, to develop models and then evaluate the performance, um, of different design strategies, of different equipment options, and then finding an optimal combination of the building envelope, of the passive features and the active mechanical features. I would also say a pretty important aspect of high performance buildings is operation. So, because good design and good construction can only take you so far. And once a building is handed over to the owner, there's no substitute really to a focused and deliberate effort by the operations and maintenance team to operate the building. I sometimes feel that this aspect is maybe easily overlooked, because if you can appreciate how in the life of a building, if it takes 1 year to design, 2 years to build, and then decades to operate. So ensuring proper operation, that would capture both the design intent and also changing building needs, because that happens in real life. So these are all really important aspects of high performance buildings. And then, not really in contrast, but a traditional building or typical building would have some of these features, and the whole process may include some of these things, as I just mentioned. So there may not be a clear difference between a conventional and a high performance buildings, but differences would be along these lines that I mentioned.
So then, Andre, would it be safe to say that the design of high performance buildings is much more complex in nature? The equipment is much more complex and more expensive, and also the maintenance that's required is much more and complex. Would it be safe to say that?
It would be, yes. So though all of those are true statements. So um, inevitably, the higher performing building equipment will have to be more expensive and more complex to purchase, to set up, and to include. Higher performing building envelope, you know, inevitably would be more expensive than like more traditional building envelope. So all these are valid, very valid components for sure.
Makes sense, Andre. Now, could you walk us through, the step-by-step process of designing a high performance or a sustainable building? And would this process be the same in Canada and in USA? Would love to learn more on that.
So first of all, I haven't had first-hand experience in US projects, but from everything I know, from all the literature I know, from all the videos I've seen, from everything, the process is completely identical. So the process typically, in a typical building, would start with an owner or investor, who would approach a design team. So the owner or investor can be a private entity, for example, in case of an office building or of a multi-unit residential building, or can be the government, some branch of the government, in case of a school, of a library, or a hospital. So anyway, so then they would approach the key design position, which is the architect, and then the architect would assemble the rest of the design team. So they would assemble the mechanical engineer, the electrical, structural, building envelope, whoever is needed, landscape, whoever is needed. So then the process may look something like this. So the team would put together a narrative that would describe how to meet owners' needs at a high level. Ideally, there would be maybe an energy analysis to quantify some of these design ideas, and to inform the team what are the most effective strategies or design approaches in achieving these goals. those can be energy efficiency, can be optimizing operating costs, operating capital costs, all of those things, and then feed the information back to the design team to produce the drawings. So then when the drawings stage starts, um, a set of drawings is being produced, a set of detailed drawings is produced. So maybe after that, maybe a more detailed energy analysis is required to complete or to fine tune the design. And then the drawings are completed for tender or for building permit. Um, then the construction would start, and there's often, so design is still involved here. So design doesn't, there's no hard stop. So there's often design changes that take place during construction, some material changes, equipment substitutions. So the design is then updated as needed. So this whole description may sound kind of straightforward-ish, but it's definitely very far from linear. So it's rather, you can think of a squiggly line that generally starts with an idea and goes up and down, and sometimes even maybe loops back on itself, but generally goes towards what the owner wanted. So the designer is still present during construction as well, like I mentioned, to provide guidance and clarifications for the contracting team. And I would say that design as such is probably completed when the building is handed to the owner, and then the building starts its new life.
So, Andre, typically, on an average, what is the duration of the design phase, and what is the duration of the construction phase?
Um, yeah, so a typical design would, um, like I said, the whole team would rally around the architect. Time-wise, say it would be several months during pre-design, or concept design, and that kind of leads into a development permit. So then once the development permit is produced and approved, then the team continues working on detailed drawings or working drawings or construction drawings. And then this process goes on and culminates with, say, a building permit application, or the project goes to tender. Sometimes drawings are updated specifically for construction, and then construction starts. So this whole process may take um, maybe 3-4 months. Like this is super simplification, but just to give you a flavor, maybe 3-4 months for the development permit, maybe even more depending how early on the design team is hired, and another, say, 6 months to a year for the detailed drawings and the development permit.
Okay, okay. Thank you, Andre. Now, while you're in this design phase and you worked on so many different projects, what are some of the maybe like the top three challenges that you've encountered in the design phase or even the construction phase of the projects?
Um, well, because of how long this whole process takes, I would say one of the big, like, I don't know which one is the big, one of the biggest challenges maybe would be team changes, because, you know, honestly, people move around every several years, or a couple of years, several years. People move around. So things are fluid from that point of view. So making sure that knowledge is retained along the design process is really important, and knowledge is handed over from one individual to the other. Um, as the design, so that would be one challenge. Another challenge may be, as the design is developed, as more and more details are being brought up and discussed, the owner's perspective may change. So the owner's need may be developing as the design develops. Um, that is possible as well. So because you don't always have, final goalpost and you know exactly what you're going to. That's often not the case. And then again, so that would be the second, and maybe you said third. Okay, so the third challenge may be escalating costs, because what may start, if you appreciate a process takes, a year, a couple of years even, depending on complexity. So a system and equipment that was priced and approved earlier on may no longer be the best solution, a year or year and a half later. So that also kind of can throw a wrench in the spoke. So I think those would be challenges that come to mind first.
Definitely very valid challenges, Andre. Now, in this building design phase, what are some of like the typical common industry softwares that you use to design these high performance buildings?
I can mention a couple. And I can mention a couple in like design tools and energy modeling tools. So in design, we would use for load calculations, like for heating, cooling, ventilation, we would use software like Carrier's HAP or Train's Trace. These are all um, can't remember if they come with any fees. I think they come with fees, but they are reasonable, and they're really widely used. So from everything that I know, huge majority of design teams are using those pieces of software. For energy modeling, we at the moment we are predominantly using eQuest. Years ago, I started with E4 and I really liked it. It had some really advanced feature for its time. This is 20 years ago. Now we have people sitting right next to me here who are experienced with IES VE, with Energy Plus. So we always try to find the software that best addresses the needs for the project, because sometimes the needs for the project could be just code compliance, in which case we can streamline that process, and other times it can be compliance with some more advanced energy efficiency targets, in which case you need to have more detailed analysis and potentially apply different software.
Now, you mentioned two different categories of software, Andre. One is associated with load, and the other associated with energy modeling. So, what exactly are you trying to achieve in the load calculations and again in the energy modeling? Could you expand more on that?
So to some extent, yeah. To some extent, they almost achieve the same. They produce really similar results, really similar pieces of information. So a load calculation software would calculate what is the peak capacity, peak, say, heating capacity needed for a system. An energy modeling software would calculate the heating needs the building would have throughout the year. So, 8,760 times in a year. So the energy modeling software would capture the sizing of the equipment and then apply, a fraction of it for all these 8,760 hours. And the software that we are using for load calculations, both Carrier HAP and Train Trace, they actually also can do hourly analysis as well. Now, I just make a distinction between those two because we traditionally here in our office we have people who are focusing on design and people who are focusing on energy modeling, and that's why I bring up these differences. But otherwise, as software goes, they actually produce remarkably similar results, and it's just a matter of which one you're most comfortable using, which one your team is going to be most efficient to use, and then, like I said, we always have to find whatever the project needs and find the right tool for the project.
Very insightful and very interesting, Andre. Now, let's say, for example, a building design is complete and the building is currently in operation and it's been commissioned. What would be like the success metrics that will be used to evaluate a high performance building? And also, could you maybe share some client success stories?
So number one by far would be the owner being satisfied. So the owner, having invested into this project, has to be happy that they got the building they need. So that would be one success story, whether it's high performance buildings or any other. For high performance buildings specifically, it would need to meet the energy efficiency goals. So unfortunately, the process is such that energy efficiency is evaluated during design up to design completion. And there's not, for my liking, there's um, not enough tools put in place when the project is handed over to the owner to track energy performance and to confirm that indeed all those um, good technologies and equipment installed are actually working as such, actually working properly. So that I think would be a really good metric. So to do one final energy analysis at project completion and confirm that yes, what was designed actually took place. Now, codes, strictly speaking, do require this. Programs like LEAD, for example, do require this kind of completion, this kind of analysis at project completion. But how diligently that is applied, that is maybe a little bit questionable. Also, I would say from design team's point of view, because you ask about efficient process or success stories. So like good um, successful project from team's perspective would be a design where that has the smallest number of changes and that goes really smoothly, right? So because of how inevitably more complex, higher performing buildings would be, this process would be a bit more not convoluted, but less of a straight line. So therefore, a project that goes smoothly with fewer changes, that would definitely check a lot of boxes in terms of being a successful project.
Makes sense, Andre. Now, what is the typical lifespan of these high performance buildings, and what is the level and frequency of maintenance that's required in these buildings?
Hmm. So lifespan. So buildings last for decades. Typical life of, say, a heat pump or an air handler maybe would be, I don't know, 50, 20 years. Boilers could be 25, 30, 40 years. And building envelope, I'm not sure I should comment because I don't know exactly, but, could be, say, 40 years for stuff like, the roof insulation and all that. This is, I'm making large approximations. Um, each of these would require regular maintenance, especially mechanical equipment, and especially the more complex it is, more, the more the more highly tuned that the machine is, more maintenance it would require. So that would range from something like a couple of months maintenance intervals to a couple of times a year, but regular maintenance is by far something that helps longevity of the equipment. And like I said, the more sophisticated it is, the more frequent maintenance it would require.
Totally makes sense, Andre. Now we are coming to our final few questions here. Where do you see the future trends in sustainable and high performance building design?
Mm.
And also, if you could shed some light into where do you see like sustainability being incorporated into data centers, which is like a hot topic these days, would appreciate that.
Mm. I can offer some thoughts on data centers. I don't have a first-hand experience in data centers, but I can maybe mention. In terms of future trends in sustainability, I don't think I'll be super optimistic. I'm afraid. Um, the really high-performing buildings, achieving, LEED Platinum or Passive House um, standards, are very far and few between. They are important. They lead the industry, so they are definitely important. But in terms of the energy consumption of the entire portfolio, of the entire buildings portfolio, you know, nationwide, they don't really affect the energy consumption that much. Now, new buildings, other new buildings, so which are not, super high performance, are many more, obviously. And the energy code in the last, say, 10 years or so definitely helped bring the bottom up. So definitely helped, but so this is great. Ratcheting things up code-wise is still possible, although mechanical equipment is already getting quite good and quite efficient. So now the accent seems to fall on the building envelope. So so some improvements are possible, but again, if you look at all the building all the buildings landscape, even new buildings are not that many. By far, the biggest impact would be on existing buildings, which they are everywhere around us. And to my knowledge, I don't know if there's a program that addresses them. So therefore, if there's no program like something that would be mandated by code, something along those lines. So then the incentive would be, or the initiative would be on the building owner. And why would the building owner want to invest, into improving efficiency when the electricity and gas costs are, still relatively speaking low? So they don't incentivize the owners to dramatically improve buildings. And so therefore, I'm afraid I don't see how we would make huge changes. I'm not sure if this is what you wanted to hear, but it's, more or less how I feel.
Well, I appreciate the realistic outlook and your transparency, Andre. So thanks for that. Now, any thoughts on data centers?
Yes, you mentioned data centers as well. So, like I said, I haven't had firsthand experience, but I can talk to you about how I would think about data centers. So, by far, key aspect of data centers is making sure they run. So they can never afford to not run because they generate so much heat when they do run, and they run all the time. Then they require cooling year round. Well, mechanical equipment as such, like I mentioned earlier, is getting quite efficient. So there's no doubt in my mind that mechanical equipment in the future will be even more efficient. But in terms of what we have seen in the last, little while, in the last, couple of decades, things have improved, and starting to kind of taper off in terms of energy efficiency. So therefore, the next thing I would look or think about in terms of data centers would be, well, where does all this energy come from? Well, and then I would contrast, these our two provinces. So, this one we are here currently living in Alberta, and the one next door. So if you are concerned about where energy is coming from, namely electricity, there's no other energy that's practical for cooling data centers, then you would probably want to build something that uses hydropower that has much cleaner energy than the mostly fossil fuel based electrical infrastructure that we have in Alberta. So that would be one thing I would think of. Um, and maybe one other thing I would think of is to improve energy efficiency, specifically for the cooling system. You probably want to have cool environment. So therefore, maybe you are prone to install something in the very far north of the country, right? Such that the ambient is such that you naturally, the naturally cool environment allows for a really efficient operation of the cooling equipment. Of course, then you have to transmit all that data potentially long distances. So I think all of these things would have to be factored in. Like I said, not having firsthand experience in data centers, this is how I would think about what sustainability may mean for data centers.
Well, I appreciate your perspectives and thoughts on data centers, Andre. Now, lastly, for somebody who's looking to pursue a career in this field of high performance and sustainable building designs, what sort of advice would you have for them?
Patience. So high performance buildings include many disciplines, like we just mentioned. So if this is their interest, then getting into any of these fields that I mentioned are a positive career development. So whether you go into manufacturing or contracting or consulting or engineering, all of these, kind of go generally in that direction. So, so they are generally going to be a positive career development if the end goal is high performance buildings. So I would say, so the reason I mentioned patience is because, even if there's a position in front of a person which does not truly feel like a dream come true, patience would be needed to see it as a stepping stone, in the gradual development of the career. So um, patience and having clear idea of what what you want to do.
Very sound advice, Andre. Now, is there any specific journals or magazines or maybe like conferences or books that you'd recommend they look up on?
I quite like the ASHRAE journal. ASHRAE puts together um, this monthly journals which cover a variety of topics. So that they cover mechanical equipment. There's articles on building envelope aspects and building envelope design. Um, there are case studies of successful projects. So if there's one that I can think of, I would really recommend it to keep in tune with what's happening in the industry, in the North American industry.
Great, Andre. Well, that concludes the formal portion of our interview for today. We like to end our podcast with a fun segment called a rapid fire, where
Mm.
our viewers and listeners get to learn a little bit more about the personal side of our guests. Now, as part of this rapid fire, I'll be asking you three quick questions. Are you ready?
Okay, let's do it.
Great. Well, firstly, as this is a tech podcast, would love to learn what's your favorite app or a hardware product that you enjoy using?
Um, a favorite hardware product I enjoyed using was a BlackBerry, which was discontinued 2, 3 years ago. And I'm really excited about the prospect. I just came across a Chinese manufacturer that's offering a hard, like a keyboard, like a smartphone with a keyboard. So I think I'm gonna go on the pre-order and subscribe for that. It's becoming available in the fall. So I'm really looking forward to that, actually.
Amazing, Andre. Now, secondly, what's a book that you have read that has a big impact on your life and why?
Um, that has big impact on my life. As a kid, I used to read a lot of books. I'm afraid I don't do that quite as much as I would like to. Um, I used to read books by Karl May. He was a German writer who wrote about the Wild West. And as a kid, I was reading about the cowboys and Indians and what the life in the Wild West was like at the time. And I think that is a really important book for me because, to a good extent, I feel it contributed to me even moving out here.
Great, Andre. And lastly, do you have any final words of wisdom, perhaps a short story or a quote that you'd like to share with members of our audience?
Words of wisdom. Um, do not be afraid to ask for help. Most people really want to help. Most people will be happy to help. Um, and also learn to say that you don't know something. Because when you say that you don't know something, it establish a more honest rapport, establish the understanding, establish the limits of your understanding. And when you build a more honest rapport with people around you, then that will make people even more willing to help. So ask for help and don't be afraid to say you don't know.
Very well said, Andre. So that concludes our rapid fire and our interview for today. How can our viewers and listeners get in touch with you?
Um, I am on LinkedIn and I check it periodically. Incidentally, that is also one really good tool for following up what's happening in the industry, to your question earlier. And also we can provide my email and people can always get back to me. I'm happy to take questions or comments from anyone.
Well, great, Andre. Well, thank you so much for being on the show today. It was an absolute honor and pleasure having you. And thank you so much for sharing your subject matter expertise in the field of high performance and sustainable building design. From the team at Energize, wishing you and your entire organization lots of growth and lots of success.
Thank you, Arjun. Thanks again for having me and for the opportunity.
So, there you have it, ladies and gentlemen, our episode for today. And remember, a greener future is in our hands. I'm Arjun Chaudhary.